In this video, we're looking at BMAT 2020, Section 2, Question 23. We have a submarine that's using the sound of frequency 6,000 Hz. The pulse of this sound reflects off an object 750 metres away, and the pulse returns to the submarine 1 second later. And we need to work out what is the wavelength of the sound in seawater. So how can we work out the wavelength, knowing the information we have up here, so the frequency, the distance, and the time? Well, our equation we're going to use is that frequency equals the speed of the wave divided by its wavelength. And we know the frequency, and when looking for the wavelength, the thing we don't have is speed. But how can we work that out from our question? Well, we know that speed is the distance travelled over time, and we do have that information. So our distance is going to be 750 times 2, because it's going there and then coming back after it's been reflected, and our time is 1 second. So our total speed of our wave is 1,500 metres per second. And so knowing this, we can put all of our information into our original equation. So our frequency is 6,000 Hz, and that equals 1,500 over our wavelength. So we could just rearrange that by timesing both sides by a wavelength and then dividing by a frequency to get our wavelength as 1,500 over 6,000. And then we can simplify that down, get rid of these zeros, that's just 15 over 60, or 1 over 4 metres. That's our wavelength. Now, this isn't one of the answers we can choose from, so we're going to need to convert this. So let's convert it into centimetres. And by doing that, we know that 1/4 of a metre is just going to be 25 centimetres. So our final answer is B.